Good morning, friends. So, next chapter is beams. So, already we have discussed column foundations. Next, here comes beams. So, in beams, how the steel structure helps to design of beams. So, already I have said we have different types. Okay, so we have different types. Inner standard lengthy beam, heavy beam, weight beam, IS, HB, WB, LB. Okay, so standard angles are different from beams. Length, long beam, heavy beam, weight beams. So long beam is nothing but the beam was so long, which are in bridges or cables, etc. Next, heavy beam. Heavy beam means nothing but the beam weights heavy. Next, weight beams. Okay, wide beams or weight beams. So here in these three sections, how the beams are calculated and known that deflections, shear forces, bending moments, whether the section which we have taken to calculate, to do the design of beam, whether the section was safe or unsafe. We should take the design criteria methods. So here in beams it has divided in two types. So one is laterally supported and another one is laterally unsupported, which comes under very important question for 14 marks. Okay, for 14 marks. So main laterally supported and laterally unsupported, there is two difference. Laterally supported means the beams will be mainly on supported, which is fixed, simply supported, which are fixed and simply supported, and the compression flanges. So in case I section, the flanges will be restrained or means supported to something, restrained or supported the compression flanges. Okay, and the flanges were subjected due to bending. The flanges were subjected due to bending and shear. Okay, here laterally supported means restrained, that is nothing but supports are fixed or free. Here unsupported means not restrained, that is opposite of laterally supported. Opposite for laterally supported, not restrained means not free. Example, one end is fixed and one other is free, like cantilever. Example. Okay, so here unsupported means not restrained compression flange, supported means restrained compression flanges. But that occurrence will be difference for laterally supported and unsupported. So laterally supported here it occurs for lateral buckling, vertical deformation and bending failure. In this beam, lateral buckling will be there, so bending will be laterally will be there. Vertical deformation will be there in means web. So in web the vertical deformation will be there, and bending failure also will be there due to time, with respect to time bending. So bending failures, what is bending failure? So load is applied over kilonewton per meter, load is applied for W kilonewton per meter, and the bending of flanges will be gradually changes. So bending failure will be there. Here in lateral unsupported, twisting and torsional buckling. Twisting and torsional buckling. So in strength of metals we have done the twisting process. So due to rotating like this twisting process, in middle the failure will be up. So if we take in some section for design criteria like ISLB, ISHB, ISWB, and we have done the design, we should follow the checks of main bending, shear and deflection. If we take an ISLB section and done the problem, you should satisfy all modes of failures, that is bending, shear and deflection. Okay, this is the modes of failures. If we done lateral supported and lateral unsupported problem, and we have selected select section like ISLB or ISHB or ISWB and done the problem, it should satisfy all modes of failures, which is bending, shear and deflection. And these modes and these design beams were based on design criteria, based on deflection, based due to bending, based on shear. So first and foremost, you should calculate based on deflection means maximum bending moment and maximum shear force. So these beams were dependent upon maximum moment and maximum shear force. So vertical deflection will be caused due to shear force, bending and shear. So all values design bending strength must be greater than shear force only. So all design criteria must be greater than shear force. If not, change the section. Okay, so after doing the problem, the all design criteria must be greater than shear force, which we have calculated maximum shear force V is equal to WL by 2 or cantilever means WL. Okay, V is equal to WL by 2 or WL, which is type of beam which we have given. So the design properties must be greater than V. If not, change the section ISLB 500 to ISLB 550, ISWB 500 to ISWB 550, or increase or decrease the sectional height. So in some problems, they will say the beam is restricted to some height. The beam, in some problems, there will be restriction of height. There will be restriction of height. We should take that regarding height section only. We should take that regarding height section only and do the checks and to solve the problem. Okay, so there will be restriction of height. This will call as built up beams. This will called as built up beams. So there are three types: laterally supported, laterally unsupported, and built up beams for doing the problem. This was the introduction class. Okay, so laterally supported and laterally unsupported. Laterally supported means restrained at compression flanges, lateral unsupported not restrained at compression flanges, and modes of failures are bending, shear and deflection. And the design criteria for based on deflection, stresses and shear should be greater than shear force, maximum shear force. If not, change the section which we have taken from code book or table book and do the problem. Okay, this is the introduction class for beams, which is very important for 14 marks. Okay, so tomorrow we will discuss the design steps for laterally supported and we will do the problem. Thank you.